Awesome. Hello, everyone. Happy Thursday. I hope everyone's having a great day so far. We are going to go ahead and get started with our presentation for today. My name is Heather Grant. I am one of the community admins here at the Maintenance Community by Upkeep. Thank you once again for making the time to be with us today. If you are not already a member of the Maintenance Community on Slack, we would love to have you join us. I will drop the link to sign up in the chat in just a moment. Today we have Andy Gailey joining for a presentation on how criticality can frame a maintenance strategy. I know it's going to be a great conversation. I'm really looking forward to hearing it and then hopefully an engaging Q&A as well. The recording from our session today will be available at this link right after we end, as well as in the Maintenance Community Slack tomorrow. Andy is also available in the Maintenance Community on Slack, so please feel free to share either the recording of this webinar or the invitation to Slack directly with friends, colleagues, or anyone else you know who would benefit from hearing some of Andy's expertise. My last piece of housekeeping, then we'll go ahead and get started. If you have any questions throughout the presentation today, please feel free to use the chat feature on the right-hand side of your screen. We'll be tracking questions throughout the conversation and then have some time set aside at the end to go through and answer anything that comes up. Please feel free to ask away. That is all from me. Thank you so much again for being here, Andy especially, and I will turn it over to you to get us started.
Thanks very much, Heather. It's good to be back and nice to see everybody virtually logging on to learn a bit about criticality and maintenance strategy. So what I've done, I've got a brief slideshow that will probably last about 20-25 minutes, but it's not very wordy. Hopefully it's quite light and you won't bore you to death. But it's kind of split into two halves. The first half kind of is an umbrella statement about criticality and how it might fit any business really that has assets. And then the second half, I go into things I'm going to share from what I actually use, carrying out criticality studies for clients, blue chip clients right down to small SMEs. And it's a tool that I've developed over the years, and instead of being the broad sweep of criticality like a lot of specialists talk about, it actually goes down into the nuances of people. I'm a very people-centric person, so it doesn't just look at the hardware; it looks at your software as well, your people, and how they might react to a different way of operating. So let's go into hopefully this, I can get the slideshow to work. Heather gave me some tips.
We practice.
Yeah, I think we're nearly there. So as Heather says, I'm an uptime consultant. Our company is Uptime Consultant Limited, based here in the UK, centrally in Coventry. Formed it 6 years ago after I came out of the PepsiCo international business, which in the snack food part of the sector. So I'd spent quite a lot of time thinking about looking at producing a predictive strategy for that business. And we went from a really kind of reactive business model to a proactive, planned, predictive type model over the years. So if we're looking at criticality, first we've got to know what we mean by criticality. So criticality is putting things into a degree of importance, either in its the quality or the state that it's in. So an analogy for my body is obviously my heart and my lungs are super critical, but there are things that probably get away with and still live for the rest of my life. If I lost a finger or a hand or an arm, they are of a secondary criticality. So the examples I'm going to give today are from my own experience. So I'm not preaching to people and saying you must do this. I don't believe in that. I believe in that you take away the information you've got and then you can build it into something that fits your needs at the time. I came to say from that high volume, intense industry of snack food, where our constraints were that we operated 24/7, probably 362 days a year, and our cycles of operation, we wouldn't close a line down probably for 3 weeks, and then have a window of opportunity to do any of our planned maintenance. And obviously any reaction along the way there just impinges on your ability to produce for your clients. So it's interesting to note that criticality is that overall thought about how important are things. So as engineers, every day, when you think about it, we are using this kind of critical thinking in the things that we do. We're asking ourselves questions about what happened, why did it happen, how can we make that better? Do we take steps to renew that piece of equipment or that asset? Do we replace it, or can we rebuild it and put it into a better state? The one thing that I find though when I go into industries and looking at maintenance is that although we go and do all of these things every day, it's very rarely that you get somebody that operates at a level and has an overall view and stands back and looks at exactly what's going on, and they can actually tell you what's going on. So many organizations either never get the time or they don't put the time aside to look at their assets in the way of how critical they are. They may think they know how critical their assets are, and usually when the first question I say is, well, okay, out of this asset group, which is most important, the reply comes back, well, everything's important. Well, everything can't be important. There must be something that's more important than the rest of the population. So what happens is, because of this, we have people working in industry are working and they're reacting to things going on around them. They are being driven by their reactive events, and they think that's right because they've always done that, and they think that this is good because nobody ever told them that actually is a different way of doing it. If we use, so when you go and talk to people about criticality, you say, well, what can it do for me? They're not really, at first, they're not really interested in the nuts and bolts and the inputs and the outputs. They just say, well, what can it give me? What kind of revenue can I see return to my business, and what kind of major benefits can I see? And that's the right question to ask, because like anything in maintenance and engineering reliability, we need to keep an eye on the prize, really, that we shouldn't be doing any of these things if they're not proven to add outstanding value at the end of the day to our business. Dropping my notes here. I've got notes here because I don't want you to miss anything, because I know I will. The people that get criticality studies wrong are the people that think it's a thing to do. So somebody's maybe high up in the business said, we need to do criticality. And then they struggle to do it and nobody gives them any help. And they end up making a file that they put on a shelf and they never ever look at it again. It should be treated as a live process that you are going to embark on, and that you are going to learn a lot about your assets and your people and your inventory and things like that, and that you are going to use as a tool to make things better, and also be able to revisit that tool in the future and see if it worked. So it's important to do that, and what it can do, it doesn't just look at, for me, it shouldn't just look at the hard assets. So I've seen a lot of things and they talk about the hard assets and the components and all of those things, but they don't go into, well, what about the people? What about their skills aspects? What about their buy-in to actually involving themselves with asset care? So all of this, to me, there's a lot of other things other than just the hard assets and components. So once coded out, it should be reviewed to gauge either has it worked for you? Does it need something changing, Also, things in industry can change over time. So a lot of the things I've been involved in, they're new lines, so there's no history, and because they're in an R&D environment, they will change over time. So some assets will disappear, and some will come into the asset kind of hierarchy. We obviously need to understand that we're going to have to invest some time in this to get the return, but the time will be really well spent. When you first start, it seems like it's a really major big piece of work, but if you pare it down into sections and into components, it becomes quite becomes a lot easier. And if you co-opt other people into the workflow, that obviously can help majorly. So the benefits part of it, for me, all of the criticality studies I've taken part in over the last 15 years, all of it has been paid for, top line, by the reduction in the spares inventory and the removal, or not putting it in the first place, of planned maintenance that adds no value whatsoever. So from an RCM point of view, we look at the components and says, you have to say, what does this planned maintenance do for our asset and for the risks and consequences of eventual failure? So I've done these things where obviously I go in as a consultant to businesses and I sell my time to carry out criticality studies. At the end of the day, I can go to them and give them a hard figure and said, well, this OEM quoted you 120,000 euros or pounds or dollars of inventory you had to purchase, and we've got it down to 12,000 euros. And that also has an on cost because the business doesn't have to carry that cost over time. So this is what people miss. If you start adding massive amounts of stock, you have to look after that stock, you have to care for it, you have to rotate it, and it is it's part of a capital investment. So that's the ROI bit in criticality. The main thing that criticality does, though, it reveals the unknowns. So we make assumptions at our own cost about assets, and by doing the criticality study, it sounds stupid, but it actually gets people to go and read the manual, and some people don't even do that if a manual exists. So it's becoming more and more prevalent that people buy an asset and the last thing on their mind, or on the OEM's mind, is to actually produce a manual, because it's become almost like an additional part of the resource for that asset, whereas it shouldn't. It should be almost up front. So the things it does, obviously, the spares inventory, you can buy the right spares or stock the right spares at the right time. It'll also, when I say frame your maintenance strategy, it will give you a framework for your maintenance strategy to say, where can we put predictive tools, if there are any that we can use against these assets? Where do we go? And we have to go and do plans. So where are the bits that law says we have to go and do it first, and then all those things that are hidden failures next. It also gives us an idea of, when we look at our people against tasks, have they got the right skill level, and have we given them the right tools to do the job? Because it's no good putting in planned maintenance and not having your people ready to go and carry that out for you. So our maintenance choices, and again, this is something obviously I'll see every either existing client or new client, is that we have some choices. The first choice is we can just have no strategy at all and just wing it. We can just say, well, we'll wait until this breaks, then we'll call the OEM up, see if they've got any spares for this machine. Fingers crossed, it'll never go wrong. And that's quite a common strategy. You could do some work where you get all the OEM manuals, you go through methodically through those manuals, you take out all of the planned maintenance, you put them into your CMS system, you get all of your technicians on board as this is what they will do, and you will also go away and buy all the OEM recommended spares. But what we have to bear in mind is that OEMs build assets. They hardly ever run them. Once you've taken the key and they walk away, their responsibility is pretty much zero, unless you're in something like the nuclear industry or something that's highly regulated. So that's the second approach. You can put in lots and lots of time-based planned things and still have the breakdowns that cost you money. And what happens then is it's like a snowball effect. Once something breaks, somebody says, well, can we go and put a PM in for that and do it every week rather than every month? And you end up with a mass of labor hours you can never cover. And if you're on a KPI chart, you'll never be able to tick the box that said you got your 93% compliance or wherever the figure says. So many take that first or second approach of let's wait till it fails, or well, let's plan everything in and go with what the OEM says, even though the OEM probably is one of the worst people you can ask for how your assets going to be used in anger. There is another way we can look at things, and we can look at things kind of proactively. We can put some lubrication regimes in. We can make sure that our components aligned components are checked on a regular basis, that they're still in alignment, they're not vibrating excessively, and we can use some predictive tools. And the first predictive tool you use is people. People is what makes prediction work for me. So if you can train your people to use their eyes and their ears, that's really the best place to start. And you can't really teach engineers to become from reactive and planned to being proactive and predictive without taking them through some sort of training that says, well, you're going to have to start thinking differently. So I worked obviously in a very for just over 20 years in that snack food industry, and it was quite uncomfortable for myself. I didn't like the reactive atmosphere because my training is as a mechanical production engineer, so I like things that run sweetly, and I like to be aware of what's going on. Whereas a lot of the cohort I worked with, they were maintenance engineers, and they were quite passionate about being busy. They like being busy. They like fixing things. They like the challenge and the cut and thrust of that. So there's a human aspect there we have to be very aware of, and we have to take these people along with us if we're going to take this journey from a reactive kind of unplanned sphere to a more proactive and predictive one. So fortunately I discovered this criticality process and things like RCM and failure modes effects about 15 years ago, because the business at the time decided, especially the engineering, the operations, they decided that we were spending too much time fixing things and not enough time running production lines. So the decision was taken that we needed to change the way we worked. So it was a journey. It took a couple of years to actually get started, and it took probably 6 years to come to the bit where you could say we achieved our goals. We went from double figures of unplanned downtime down to less than 1% on some quarters that we ran. It's quite a difficult journey to get there. You can't pull any punches about it, and it took quite a lot of time. Soft skills of getting people on board to get their heads in the right place. So that new maintenance strategy was required, and part of what drove that new maintenance strategy is we took a step back and said, well, we've got this set of assets over multiple lines, and we're going to have to look at it about what really matters the most. And there was a certain product within that production environment that drove most of the revenue. And I'm a big believer in Pareto analysis, that there's there's probably 1/5 of your business will drive 80% of all of your profit and throughput, and then the other you'll need that as a supporting function to operate. So there are choices. Now I'm not saying any of these is the right choice and you mustn't do anything else. They're all part of a maintenance strategy, even reactive. And as I'll say later on, predictive maintenance, which is a phrase I'm not very keen on, predictive maintenance is actually just the earliest form of reactive maintenance. We need a signal to take actions, and that's what prediction gives us. So when I discovered criticality, the main things when I thought about this presentation of the week was it revealed unknowns, all the unknowns that we didn't know about our equipment, we didn't know about our people, we didn't know about our ways of operating. It revealed those for us. It restored, over time, it restored some order and confidence. And the confidence came from the operations part. So the operations part of the business really didn't understand what maintenance did. They wondered what we did. We just we seemed to break things and then fix them. But if you can start getting some higher figures of throughput and availability, it restores that confidence and order with your operations and maintenance. And the best thing I've seen is that engineering function and maintenance function working hand in hand with operations. So the goal, we must also understand that the goal is to work towards the production that we require. So this thing that we're doing, this criticality we're doing, we're not doing it for the sake of criticality. We're looking at an overall goal, and these are some of the things that for me fit within this criticality journey. I'm again believing RCM, reliability center maintenance. So we have to use that when we look at our assets. To do things like prediction, we need to know about failure modes and the effects on our risk and consequences of our business. And then we have certain, and these aren't exclusive. We've got to know about what our people know and understand, their knowledge, our own knowledge about our assets. We've got to kind of share with them that there is a predictive way of going about things, and that lubrication and a robust CMS system is part of that journey. So this is a second part. So I'm going to share some screens here now with the actual process I use. And to carry this out, you obviously need inputs. Like any baking a cake, you need ingredients to put into this. So you need a full asset list. You need a complete set of OEM manuals. You need the OEM to provide you with their critical spares list. It's one that they say you should have. Their recommended planned maintenance routines. You need your own, if it's an existing line, you need your own history of any unplanned events, what happened over the past couple of years. You've got CMS system. You need your existing CMS system open so that you know what parts already exist, because there will be some duplication amongst parts, that you can identify parts against new assets that you brought into the business. Any existing planned maintenance you've got, if it's existing plant, any condition monitoring, that's if you have any, and if you don't, then you need to think about what applies to your particular assets. A skills matrix and the availability of those skills. So you need to find out where people are on the scale of what they're capable of doing. We also need the availability with the criticality study itself. You need some of these parties to come along to the information gathering part. This level 1 part of it is crucial, that you get people that are involved in health and safety, the operations manager, production managers, people from actually the operator group, the maintainers. So you need to get these people involved. This is it comes from a macro level. So you look at a high level across your whole asset group, and then you're going to have to decide which one, say if you've got multiple lines, which one of those lines is the most critical. And that will usually be the one that generates the most revenue for the business. And go and do your initial study on that one. Do not go and do something that never runs or is very, very low criticality. You're just going to waste your time on that. Go for the thing that's the most important thing in your whole plant, and then cut it down into sections and start section at a time. So this sounds like a lot of information you have to bring together. It can take, I mean, my experience, it can take a couple of days. Or if you've got a really good client, they can bring all this stuff together in a room somewhere or in PDF files, and you can have it, within hours. So if you've got a CMS as well, you need a historical view of what's been going on with the existing plant. And in this level 1, what we do is we look at the headline asset. So for instance, it could be in the food industry, it could be an oven or a fryer, or it could be a packaging machine. So it's a piece of equipment that takes up a specific function, but it's probably made of multiple subcomponents of the asset. So there's motors and gearboxes and bearings and chains and rollers, all sorts of things in it. And if on this sheet you can put in a whole line here. So you put in your asset description. If you've got your capital asset replacement value, you can put your asset replacement value, and then you usually have 6 to 8 kind of sections that you're going to score these particular assets against: safety, downtime, production, quality, what we've got there, maintenance task, if there is one, the financial impact, and it comes up with an overall score. So that's the bit where we look at scoring those particular sections, and the particular assets go here. So you if it's a very complicated asset, you might only have one on this first sheet, but if it was not so complicated, you might have half a dozen or a dozen. So in the second level, we're going to look at the component level. So we drill down and say on that oven we'll have motors, gearboxes, bearings, pumps, some other auxiliary drives, belts, rollers, spur gears, inverter drives. All of these things will flow into this sheet, and this is where you need to know from your OEM what the what their costs are. So the supplier costs. So you have to know what that gearbox will cost from that supplier, because you may be able to go and put it against your own existing component supplier. So if it's for instance here, if it's an SEW motor, it's maybe a standard motor gearbox that you can have an arrangement with the motor drive manufacturer rather than the OEM. That's another place where you're probably going to save 10% on procurement. You mustn't lose that support of those components you can only get from your OEM. Obviously, you need to keep them kind of sweet in the journey, but some of them are quite adaptive. So if you go to them and they've got a list of 50 components that they recommend you buy, and you've done your criticality, you say, well, I really want to buy only 20 off that list, but also I want you to give me some sort of a discount on it. They can be quite accommodative with that, because a lot of the times they'll put the OEM spares list out and people don't buy anything. So it's always worth asking them. That's the thing, always worth asking them. If we go into the third part of it, this is the part that I had actually had some input into doing this for my past employer, because I ran the condition monitoring and lubrication strategy there. So what you do here is we do the things that a lot of people never ask. What's the lubrication in my unit? what grease am I going to use, where am I going, what time schedule I'm going to put on it. Can I put it on a predictive? So can I put some condition monitoring against it that will tell me to do it on condition rather than on time, because we'd always prefer to do it on condition. So that's a really good tool. Over time, you can go back to that. It actually becomes, for some clients, it becomes a sheet they go to when they want to know what they're going to do with their assets after criticality. Into level 4. Now this is the criticality for the actual components. So when we talked about the bearings and the chains and the gearboxes and the motors and the seals and all those things that we might consider putting into this component list, and we have to be careful that we don't put everything into this component list. So if it's door handles or wheels or things that you look at and you go, well, I'm never ever gonna want one of these, and if it did break, it's not going to change my life, that obviously doesn't go in here. Well, my way of thinking about it, we always look at the rotating part of the equipment first, and we then, this here is a weighted score over all of the attributes of a particular component. So we look at the probability of it failing, of experience or out of a CMS, the severity, so the impact, so how much time we're going to lose. Is there an alternative we can use for the effect part of it? Is there do we use any detection methods? So have we got automatic detection on there? Are there warning signs? Is it monitored? And then we look at the criticality of our particular asset. Is it a subcomponent of a complete asset group that we can do without while we get it back up and running? So does it stop just the machine or the line, or is it a compressor that stops the whole plant, for instance? We get into level 5, and some of that component information, by the way, is transferred directly from level 2 into level 4. So you can join obviously the spreadsheet from one sheet into the other to fill your database. And then this part, we look at on these particular components, what kind of maintenance can we do on them? So do we need an operator? Do we need a technician? Are we going to do it on a time basis? What's the condition monitoring type that we're going to use? So we're going to use ultrasound. Are we going to use vibration? Are we going to use oil sampling or acoustic emission? What kind of condition monitoring we're going to use? And this is where this sometimes flushes out some of those training needs. And an example of that, a place where it only became apparent when doing this that the operator group were carrying out temperature measurements for safety reasons once per shift, and they were logging it, and nobody particularly was looking at it. The problem was when I looked at that, they were using thermography equipment that they'd never been trained how to use, and all the results they were getting from it were false, because they were pointing the thermal imager at stainless steel units and basically taking the temperature of their reflection. So yeah, this thing kind of it always reveals these unknowns that I've talked about. Just check where I am. So yeah, so the whole point of criticality is to give you an overall picture, and this is where I say it can form your maintenance strategy. You always should think of the risks and consequences of our assets and components. And the last piece, then we can extrapolate some of that previous stuff and say, okay, well, do we need to put a planned piece of work in for this? And we could get together with our maintenance team with this one, and with our planning team, with some of the operators, and we look at the skills level they require. Do they need any support? Can they be buddied up with each other to do certain low-level operations. And we can only expect our operator group to engage if we give them the tools and the training to engage. That's really the end of the day. That's all you can do. So we need them to, if we need them to get on board, we need to support them. And it's important to get the people involved in this part, because I've found the most effective maintenance that takes place is the maintenance practices that come from the maintenance group. So if you can get somebody to come up with an idea or a way of maintaining equipment and have the input into writing that task, that instruction, they own that, and they'll have that ownership will instill some additional support in looking after those assets. So criticality delivers on many levels. I said in the title, it can enable us to come up with a framework for our maintenance strategy. It puts everything into a single document. So once you've done this work, you have this document that doesn't just sit on a shelf. Hopefully it sits on a database that's shared and that people have access to, and it's for future reference. And annually you go back to it and you'll look at what happened in your CMS with your unplanned events, with your planned events, say, did this really deliver what we wanted? And if not, let's look at the criticality and let's see where we need to alter it, because you'll never do one and it will sit there forever and it will completely cover all of your risks and the consequences of failure. By revealing these unknowns and truths, it can have a really, I mean, probably the biggest effect out of criticality. It builds our knowledge of assets because, for a start, it gets us to read the manuals. It gets us to actually go to the manuals and say, are these manuals actually fit for purpose? Because a lot of the manuals I come across nowadays, they are woefully lacking in being fit for the asset that's being operated in the environment it's operating in. The tasks and the instructions are decided on the value they add to the business. They're not decided as a reaction to something else that happened. So they, with that input from the maintenance group and the operations, it's important. The skills gap, as I said, is revealed. So we also find out things that we need to go do. We need to go support our people with. And again, it identifies the critical spares we need, not the ones that we take from the OEM that they think we need, but the ones that we go through a process of failure modes and RCM analysis and say, well, does this fit our experience of the past? Is it proven that we need to hold on this? It's very important to do that, because some of the clients I go to, I said, how much does it cost for you to put a new spare on stock? And they don't know. They don't know because they have the procurement department or maintenance department, and somebody does it, but it's very hidden what they do. Now I know how much it costs because I actually go and do this for clients, and I could say to them, well, for every new part that you want on your stock, on your database and on your CMS, and then against your asset and identified, and all of the levels put in, whether you should be 0 or 1 or all those stock levels, it costs about £20 per item or $20 per item. So you can see if you've got 100 items, it's probably bearable, a couple of thousand. But once you start going to hundreds of items, it costs a lot of money just to put it on stock, not to manage it, just to put it on stock. So I tried to keep the slides simple. Many thanks for your time. Hopefully you got some Q&A. And what we've got to remember that it's not about the process that we're undertaking with criticality. It's about what it delivers. It's about what it brings to the business. too many people get wrapped up in the process, and then they forget that the end goal is delivering value. So hope you enjoyed that, and hope you've got some questions now. I haven't.
Yes.
I haven't.
There are a handful of questions in the chat. Thank you so much, Andy. That was really awesome. I appreciate your narration style and really explaining things through stories and all of that. So we did get a few questions in the chat here. I'll start asking them, but if anyone else has any more questions, please feel free to capitalize on this time with Andy and send them through in the chat. Our first question here says, criticality and operating context, are they the same?
No, your criticality will take into account your operating context. So as an instance, for an instance, you could have two identical pumps built on exactly the same day in exactly the same factory, delivered to the same client. And if that client puts them in different operating contexts, their criticality could be completely different. So if one's if one's used in an auxiliary fashion and one's used on demand, then obviously the one in demand will be the higher criticality. One thing I had my notes, and I did drop one of them, so I lost a bit. But one of the things to note is when you're looking at that as well, that you should expect that when you do that first part of the list, that a fifth or 20% of your assets will drive towards the top. So there'll be the heart and the lungs of your operation. There'll be the bits that are really, really critical that you'll die by. So your compressor that runs your whole factory. And some people miss that. The utilities can be the most critical things on the whole plant. And then there'll be a midsection. There'll be these kind of grey areas of probably 60%, it could be 40% or 60% of assets that kind of level 2 criticality. They'll be painful, but they won't kill your whole operation. And then you'll get a 20% population. So it's interesting to get an idea of what that 20% population is at the bottom. That's a level 3 or 4 that you can kind of not forget about, but you can put them to the back burner, concentrate on the high level ones. So once you do that first list, if you've got 20 assets in there, concentrate on the top 5, take them through the criticality process. You'll probably have then multiple spreadsheets. So context is important, and criticality asks the questions about it. Thank you for that question.
Awesome. Another similar question says, risk and criticality, your thoughts?
Yeah, the whole headline of criticality is risk and consequence. So it should be a mantra that's on everybody's mind when they're looking at engineering, reliability and maintenance, is we're looking at the risk and consequence to in the safety aspect to the person, to the business. It could be in the compliance part to the overall kind of what do you call it, the way the business is conceived in the outside world. Now it's green credentials. You've got to be, if you're not doing something about reducing your power usage. I forgot what the question was now. So, yeah.
Risk and criticality.
Yeah, right. So yeah, risk. Criticality looks at the risk and consequences constantly from a high macro level all the way down to the component, all the way down actually into say, is it the right lubrication that we're going to be using in our assets components? Because the OEMs get that wrong. Because the OEMs never know really how you're going to use this asset they've built. It's like they build assets and they deliver them, and then straight away operations will want to change the context. I can tell you that now. So if it runs 1 ton an hour, operations want 1.2 ton. So the context will change almost immediately, or it will change over time. Somebody will modify it, and actually the best time to do this criticality process, if you can, and I'm lucky I do get to do this with clients, is do it at the design phase. So if you can do it when the people are procuring the equipment are actually thinking about the design, you can intervene there. You can say, you do know these bearings are rubbish in this fryer, and they will cost you many, many thousands of dollars in component, not just in components, but in downtime. And you can get them to, in the past, I've got them to change the OEM's requirements, the specification, and to put in a bearing that that has longevity, that it lasts, it's fit for purpose. It's becoming a bigger risk now as well. One of the things I thought about the other day and I didn't mention was the logistics of things now. The supply chains used to be so robust, but now they're very disrupted. There was a program I saw the other day where an Italian manufacturer that manufactured bike components for the US purchaser, the price of that component would be 30% more than selling it in Europe, because the shipping costs had gone up by 10 times. So a container that cost $800 to go transatlantic just 2 years ago now costs $8,000. So there's a whole piece that's coming into now where supply chains are going to be, it should be in the top of everybody's minds now.
Awesome. Some more questions coming in, which is awesome. So the next question here says, sometimes criticality may be inherited from the superior equipment of the asset hierarchy, when it is a right way to go and when it is not.
Sometimes the criticality can be inherited
from the superior equipment. When is that the right way to go?
Yeah.
And when?
So that's why, so on that first level of the tool that I use, we look at the particular asset. When I talk to clients about it, I say, well, it's like you're using a drone or a helicopter when you look at your component, your asset group, and you look at it and you say, well, what do these parts of the production line give us? What do they do? And historically, what kind of problems do they give us? And then you pare it down into particular maintainable assets. So you wouldn't do an asset criticality on just a motor gearbox on, say, a tortilla sheeter. You do it on the whole sheeter or the whole oven, and then that becomes a subcomponent of that. So the criticality of you'd use the same process, the same thinking, but the criticality of an oven, say, would be completely different from a seasoning unit, where you may have 12 seasoning units and you'd have redundancy, or you'd have, only have to use 70% of the population. So you would never transfer exactly the same criticality from a class 1, say, oven to a packaging machine or a tumbler.
Awesome. Next question here, kind of along the same lines, I think. For component criticality, why is unpredictable detection such a low score? If the detection breakdown of equipment is unpredictable, shouldn't that mean it's more critical and should be looked at?
Yeah, okay. So what happens is I'm just trying to think how that sheet goes. In fact, I've got it here. I haven't got it big enough. Yeah, so I think it goes from unpredictable to kind of automatic condition monitoring and prediction. And to be honest, you don't really want to get too caught up in the nitty gritty. The problem people have is when they use processes, they get so in depth in the process that they lose their idea of what the goal is. So those scores, they go into a calculation, which is a kind of standard calculation. I think it's kind of the first 4 measures are times in brackets divided by your condition monitoring, I think, then divided by 2, and it gives you a score. It gives you a number, and that number, you can put that number in a band of, is it green, is it orange, is it red? So just to give you an idea of, are you triggering, well, I need to, it's a tool to say, oh, look at me. So you can look at that and go, okay, if it's got a score of anything above 1500, I'm going to go and look at you. So because when you've got that populated, I mean, you can have like 200 or 300 lines. It's, it can become very busy. So, but to go say, well, oh, should that have a 2 or a 1 instead of a 3? That's a little bit. Well, if you want that to do that, you crack on and do it. But for me, it's missing the point. Is you need it to give you the overall. Do I need to look at you, or do I need to not? No, I can honestly say when you do those criticality things, you become aware of it, and the measure usually only highlights about 2 or 3% of all those components. And so you'll say, okay, these are telling me that I need to go and stop these. But then you'll have, so what I didn't show you, that I have another branch to that that gives low component cost, but multiple components. So if you've got 100 bearings that cost $3 a piece, you put that in a different calculation and it comes out with, we're always going to stock 10 of these because we've got such a high population, such a low value that we're going to stock them. It's stupid not to, it's counterproductive. It costs you more in shipping to go and buy 2 bearings at $3 than it will to put them on the shelf. And to be honest, you'll probably have those bearings, those ubiquitous bearings of 6008s or whatever, actually on your shelf. And that's the reason why you have your CMS in your list that you've already got of your spares, and you feed that, you data cleanse it, you feed that into what you're already doing. So you go, oh, okay, so that's why you always got to have somebody within the business that knows how to run their CMS search. So you go, well, I work with a client that I worked on their databases for 2 decades, so I can go and search and I can say, well, here's all the bearings, here's all the roller bearings, here's all the linear bearings, and go down and see whether we've already got a component number for that. You can put that straight into your database against that component, and you can tell your OEM then, I don't need to buy those because we've already got them. We don't need to buy them again. Sorry.
Don't be sorry. Great answers to the questions. Yeah. It's all very appreciated, I'm sure. I have a quick question, and then I think we have just one more after that. Okay. Quick question. After the analysis is performed, how often is criticality reviewed? Annually? I believe you said annually.
Yeah, so I would recommend you go back and if there's any major change in the way your asset group is either performing, or somebody's gone and bought a new asset and put it in. So I've had this actually on a criticality study I did, and then 9 months later said, oh, by the way, all of this area we're changing. We're in a new mixer, in a new feeder, a new sheeter, and we need you to come back and do that component group. And we kind of swap one for the other. But you should take a look at it probably once a year. And if it was really, if it's really critical, if it was infrastructure or oil and gas, or I'm sure they go and look at theirs every kind of quarter, every 6 months. Once you've done the criticality, which from my point of view, I can look now at an asset group and go, well, that will take me, say, 12 days to do that. Sometimes it might be longer. Sometimes it might be longer if it's new assets. It's not already existing. But when you go and review it, it'll probably only take you a day to go review the document, to go through it, to go to ask some questions of the maintenance department, go through the CMS, see what happened. So yeah, I would say that's the main thing people should do is think about, well, put a mark on it in stone, say, okay, in 12 months time we'll look at that. But if anything major happens in the meantime, if a major failure takes place, it's always worth going back in the criticality and say, well, what did we do about that? Why did we have so if you had a stock out, you didn't have that part, you go back and look at the criticality and say, well, what did we miss? Did we miss it altogether? Did we not know something about that component? Was it being used differently to what we thought? So yeah, review it, but it should be a live document. It should be not, on the shelf and just gather dust. It should be a live document.
Yeah, something you're using regularly. Awesome. I think our last question for today is, how do you integrate RCA or failure modes with Criticality?
Okay. So I'm fortunate in that a lot of the clients I deal with, my main client is still PepsiCo. So when I go and look at their assets, I understand how they fail, why they fail, and I also understand things about their procurement processes and their kind of the way they gatekeep it and things like that. So I would say to do criticality effectively, you need to understand reliability centered maintenance. So you need to go away and either take a course on RCM. You need to go and buy one of these books, or I give away these. That's why I got multiple books here. I give them away to people. So I would go to a new client and I introduce them to some of these methods. And then one of the first things I'll do to them when they start paying me for work is I'll give them an RCM book, and I'll take them through the first parts of that RCM book to get them to understand it's a different way of doing things. So yeah, you need to understand FAMICA for me, because that's got a criticality analysis part in it. You need to understand failure modes to be able to take choices about what predictive things you're going to put in. So that's what I say. It's you can't just talk about criticality in a box. It's got all these other aspects that are aligned to it that kind of make it a wholesome piece of work.
Awesome. Well, we are doing perfect on time. That was our last question that we got in today, and just 2 minutes short of the hour. So really appreciate you taking time to do a thoughtful Q&A with all of our attendees today, as well as thank you again for the presentation.
That's cool. Yeah, anybody can reach out over LinkedIn. I'm on there every day. They can go to uptimeconsultant.co.uk. You can also find me on Instagram. I have an Instagram account, so go look at that. And that gives you some more of the kind of personal stuff that I do. So some of the cycling things I do, and all allied as well. It's all kind of tied into reliability and criticality, lubrication. So yeah, reach out. I'm always good for a conversation. And
yeah, awesome.
I hope you all enjoyed it anyway.
Oh, I did. Thank you once again, and I hope you have an awesome rest of your evening.
I've got to say, it's part 2. In August is a part 2.
Yep.
Where we're going to proactive and predictive. So look out for that on the, I think it's 25th.
The 25th at the same time, I believe.
Yeah, 25th. I'll see you then.
Oh, awesome. Okay. Thanks so much. Have a great rest of your day.
Bye-bye.
Bye-bye.